Alright, welcome to the video for Derived Units Notes. I'm sorry that I couldn't be in class today. I'll be in class tomorrow to answer any questions that you have on this stuff, and then on the metric conversion worksheet as well. So don't freak out if you are freaking out. So please stop, don't do that. It's all going to be fine. So in science, we have two types of units, not like either mass or volume, but like specific things that they fall under. First type is fundamental, so that's kind of the simple stuff that we've talked about, so like grams, meters, that kind of thing. So they're going to be like one thing, if that makes sense, one letter, nothing multiplied or divided in it. A derived unit is going to be a little bit more complicated. So a derived unit is anything that isn't just a single letter, which can be tricky. So, for example, you probably have heard of density before. Density is kilograms per liter, depending on the definition. So we have kilograms divided by liters. We have two separate units kind of squished together. Sometimes those units, even though they're multiplied, divided together, have an abbreviation that is just one letter. So it's kind of tricky. You can't just look to see if it has more than one letter or not. There's a little more to it. So some examples of derived units that you've probably heard before. Area, volume, density. Definitely three that you for sure have. Velocity, acceleration, maybe not as much yet. We'll talk about those as we go through this. So area, the square meters. So we have meters squared as the symbol. If we look, we have like meters times meters, basically. So just like if you have x times x, you have x squared. You can do the same thing with these letters that are units. So don't let that like freak you out, the fact that it's not x. Volume is something you've also heard of before. So you have cubic meters, m to the power of 3 in this case. Something that I just mentioned. Density. Density is going to be kilograms per cubic meter. So you have kilograms divided by meters cubed. So you kind of have a double dose of derived unit there because you have kilograms divided by, so that makes it derived, and you also have meters cubed. If it was just kilograms, it'd be not derived, but fundamental. If you had just meters cubed, it would still be derived. It's the one that's literally right above it. Meters per second, so meters divided by seconds. We're going to start using that a lot. And then acceleration is meters per second squared. So give you a second to make sure that you have this all filled out. These are ones that we're going to use a lot first semester. As we go through the class, we'll start to use some that get more complicated and more complicated. So kind of some of the ones to look forward to, maybe, that get to be a little tricky. So these all should be very obvious that they're derived because you see the squared, you see the cubed, you see things divided by each other, that kind of thing. The ones on the next slide are a little bit more complicated. They can be tricky. So we have force, energy, power, pressure. Force is measured in newtons. Newtons has the single symbol N, but its actual unit is kilograms times meters per second squared. The reason that they shorten this is because we use newtons so often, it's a pain in the butt to write the second part all the time. So that's why we shorten it to N. If you just see N, though, it's not just N. That's not a fundamental unit. It stands for something that's more complicated. So technically it's a derived unit, just to make things complicated for you. Energy is in joules. Joules has a similar story. Kilograms times meters squared per second squared. Pain in the butt to write every time. We're going to use energy a lot. You've probably already used energy in your life, depending on the classes that you've taken. So you're just going to see the letter J. more complicated than just being one letter. Keep that in mind. Power is in watts. We used watts a little bit yesterday in class. Again, simple symbol is just W. Technically, it's joules per second. So even just part of it is derived. If you look above, joules is actually kilograms times meter squared per second squared. So it gets all sorts of complicated when you plug in this long form for the J down here. Pressure. In chemistry, we talk about pressure typically in atmospheres. In this class, pascals are what we're going to deal with most of the time. Super similar to what it was before. It is derived though, so if you look, we have newtons. Newtons is more complicated than it seems. So you have kilograms times meters per second squared over meters squared. So again, if we replace this n with this stuff up here, it gets way complicated. So typically when we use these units, we're going to use the shorter symbols because it's easier to write. But sometimes keeping in mind that they're derived actually helps us with the problem a little bit more than you might think. So it's okay, don't freak out now. It's all going to be great and fine and wonderful. And then I'm going to kind of talk about how they get complicated. So yesterday in class, we talked about using dimensional analysis to convert between things. It's probably a little bit easier to use the loopy method, but there was a method to my madness with showing it to you then. So if I use dimensional analysis, I'm going to do two different examples, kind of just simple ones. So I have 1 meter. I want to convert it to centimeters and millimeters. Meters, centimeters, and millimeters are all fundamental units. I don't have anything multiplied. I don't have anything divided. MM might be a little tricky, but it's millimeters. I'm not multiplying, dividing anything in it. So to kind of start out, I always start with times a fraction bar, my given being 1 meter. So I have 1 meter times a fraction bar. I need to know what I want to put above and below the fraction bar. So look at my table. I can see 1 meter is the same as 100 centimeters. I don't think it says that on the table. Technically, your table probably says 1 meter is 0.001 centimeters. So I'm sorry, go with it. It's okay. I want 1 meter to cancel. I'm going to put 1 meter on the bottom, which means my centimeters go on top. I'll multiply it out. 1 meter is equal to 100 centimeters. Fine and done. Hopefully that makes sense. If I do this one, I should know that 1,000 millimeters is equal to 1 meter. You might have 1 millimeter is 10 to the negative third meters. That's also fine. So I'm going to start again the same. So I start with 1 meter times a fraction bar. I want meters to cancel, so I'm going to put 1 meter on the bottom. I want to get millimeters at the end, so I'm going to put 1,000 millimeters on top. Plug that in the calculator, I get 1,000 millimeters at the end. So that's the simple dimensional analysis way for fundamental units. This process gets a little bit more complicated when I ask you to do it with the derived units. So this time we're going to change the question a little bit. I want to find the volume of a 1 cubic meter cube. I want it in cubic centimeters and cubic millimeters. So the process kind of starts the same. You need to know what is going to go in your fraction bar. So I'm going to take 1 meter cubed and turn it into centimeters cubed. I don't have a table that has those numbers on it, but I do have a table that tells me how many centimeters, how many millimeters are equal to a meter. So if I take my number from before, I know that 1 meter is equal to 100 centimeters. I don't have the unit meter though. I have cubic meters. So what I have to do is cube the left side in order to make that unit the same. But I have to have equal parenting. I can't do something to one side of the equal sign and not the other. So I cube the other side as well. Something important to note, I can't just cube the unit, I have to cube everything on that side. So I have to cube the centimeters as well as the 100. I have to cube the meters as well as the 1. So when I do that, I know that 1 cubic meter is equal to 1,000,000 cubic centimeters. So a little bit more than like 1 in 100. So that changes how you convert it. So now my next step is kind of the same as we did before. I start with my given, which is 1 meter cubed, times a fraction bar. I want cubic meters to cancel. So 1 cubic meter will go on bottom. I want to get to cubic centimeters at the end. That's what's going to go on top. Multiply this out in my calculator. I get 1,000,000 cubic centimeters. So everything else is the same as it was before. The only thing that changes is the numbers that I'm going to put in the fraction bar. So make sure you're careful with doing the multiplying and dividing with that. You might want to pause the video if you need more time to write. Our next example, I'm going from meters to millimeters, but not just regular ones, cubic ones. So I'm going to go from 1 cubic meter to cubic millimeters. Start out the same. I need to make sure I know like 1 meter is equal to 1,000 millimeters. I need to make sure that my units match so I can actually do the math with them. So I'm going to cube the meter side. If I do that to that side, I have to do it to the other side. Equal parenting. Can't do like one thing to one kid and not the other. So if I plug this into my calculator, I'm going to have 1 cubic meter is equal to 1,000,000,000 cubic millimeters. Can't just cube the units, you have to cube the number too. You have to cube everything on both sides. It's a weird thing to get used to. Once I have this value, I'm good to continue the way that I was going before. So I have 1 cubic meter times a fraction bar. I want cubic meters to, so that's going to go on the bottom, and I want millimeters at the end, so that's what's going to go on top. If you want to, you can wait to actually like cube these numbers until you get to this step. So like you can plug this 1,000 millimeters cubed. You can put that at the top of the fraction bar instead of the one that's already done out. Just make sure not to like forget to do it eventually. You can't do 1 times 1,000. You have to do 1 times 1,000 cubed. If that just confused you, do it the same way that we've been doing it. Ignore what I just said. Plug this into your, you get 1 billion cubic millimeters. Spoiler alert, anything times 1 is 1. So you have to be careful. Make sure you watch what type of unit that you're converting between. If it's something that's like multiplied, divided, squared, cubed, that kind of thing, you're going to have to do it this way. So you have to use the dimensional analysis on these. Loopy method still works on the ones that are fundamental, just these are different. The other thing I want to do today is manipulating equations. A lot of times in this class, we'll have a complicated equation, we want to plug numbers in. It's easier to move the letters around than it is to move the numbers around sometimes, depending on how complicated they get. So we're going to kind of start out with some easy ones, just to kind of, or not necessarily easy ones, but just with some examples to get used to doing this process before we get to the point where we have to. Give you some practice first. So in this case, I want to solve for m and f equals ma. In order to do that, I'm going to treat this just like I would x's, y's, and numbers in algebra class. I want m by itself. I need to get a to the other side. Right now, m is multiplied by a. So to get it to the other side, I want to divide by a. If I do something on one side, I have to do it on the other side, equal parenting. So I'm going to divide by a on the other side as well. Once I've done the same thing on both sides, I can start to cancel out whatever I've done. So look, the a's should cancel. They should be gone on the right. So I'm left with m equals f over a. I like it when like the thing I'm solving for ends up on the left. So normally I'll reorder it at the end. But you should have m equals f over a to solve in that one. Kind of starting out with maybe a simpler one. Hopefully that makes sense. Let's try something a little more complicated. So this time I have f equals mv squared over r. I'm solving for v, so my goal is to get it all by itself. First thing that I notice is that there's an r under the fraction bar, so I want to get rid of that. I want to get it to the other side. I'm going to multiply by r. Whatever I do to one side, I also have to do to the other side. Once I do it to both sides, that the r's cancel. So to kind of clean this up a little bit, I should be left with f times r on the left side equals mv squared. Not quite there yet. I want to solve for just v by itself. So next thing I see is that I have an m on the right side. That looks like it's probably easy enough to get rid of. So it's multiplied, so to get rid of it, divide by m. If I do it on one side, I have to do it on the other side. Once I've done it on both sides, it looks like it's ready to cancel. So cross out my m's. Looks like I'm left with just v squared on the side. Clean it up a little bit. This is what it should look like. So now I have v squared by itself. I have to have the letter by itself if it's squared or cubed before I can do anything about the squared part or the cubed part. So now that I have v by itself, I can get rid of that squared part. The opposite of taking something to the second power is to take the square root of it. I like it when stuff is on the left side if I'm solving for it, so I'm going to rearrange it that way first. And then I'm going to square, or take the square root of it. So if I take the square root of one side, I have to take the square root of the other side. I can't just pick one letter to take the square root of. I can't just pick the top. I have to do the square root of everything. When I do that, the v squared goes away. I'm left with just v. I can't do anything on the other side. I can't take the square root of any of those things to simplify it at all, so this would be my final answer. I'm okay with you having that radical on the bottom. I'm not going to force you to change it at all. Hopefully that seems fair enough. So it's a little more complicated. Let's do something that's a little bit different again, just to kind of get some more. So this is a common one. We'll start doing this equation in chapter 3. Sometimes we have more than one v in an equation. Sometimes we have more than one of the same letter. And so we'll have something that we measure at the beginning, and we'll have something that we measure at the end. So in this case, I have final velocity squared here, final v, and then I have initial v over here. I want to solve for the initial v. So looking at my equation, I can't do anything about the squared part until this is the only thing on this side of the equation. So I'm going to have to get rid of this part first. This is added in the equation. So to get it to the other side of the equal sign, I'm going to subtract it. Whatever I do, I have to do to the other. When I subtract the 2AD, it cancels on the one side, and then it's subtracted on the other. So I kind of rearranged it and got rid of the extra stuff in one step. Hopefully that, you can keep up with that. Now I have vi squared by itself. I can do something about the second power. So same thing as the last one. In order to get rid of the square root, I'm going to take the square root. Here's where it gets a little wild. On the other side, I have to take the square root as well of everything. On the left side, I'm going to be left with just vi. I can't do anything to the squared thing on the right side. If it was the only thing under the square root, I could, but I have minus 2AD. I can't take the square root of this without taking the square root of this. I have to do it all together. So it's going to stay the way it is. There's nothing else I can do to simplify that with the square root. So that's my final answer. As you kind of get used to doing this, you'll have a better idea of what it should look like at the end. Last one, this is the most complicated one, and I know that some of you it's going to bother you because you're going to think that you can do it a different way. This one's a little bit more complicated than it looks. So this is, like if you want to be an eye doctor, this is going to be a common equation that you'll use in your life, not to like scare you away from doing that. It's just optic type stuff. So I want to solve for the p, which is in the denominator. All of my variables are in the denominator. Whenever I see that, I don't like it. If there was something in the numerator, maybe, but like, I hate it when I see this. My first reaction is that I want to get everything in the numerator. In order to do that, I look at everything that I have in the denominator. So I have f, p, and q. I'm going to multiply everything by those three things. So I'm going to multiply everything by f, p, q over 1. Do it on the right side. I have to multiply both 1 over p and 1 over q. So there are parentheses. You have to FOIL it. So I have to multiply it by this one as well as that one. Whatever I do, I also have to do on the other side. So put it there so I know that I'm going to do that. Next step, I'm going to actually multiply them out. So on the left side, when I multiply FPQ, I'm going to leave everything kind of the way it is. I'm going to FOIL the right side. So if you multiply everything, you should get FPQ over F equals FPQ over P equals FPQ over Q. I used to have 1 over F here. I used to have 1 over P, 1 over Q, so I fixed it so that I multiply by this. Now you should see that there's some canceling out you can do. I have an F on the bottom, I have an F on the top, those cancel. P on top, P on bottom, those will cancel. Q on bottom, sorry, that's the Q on top, Q on bottom, those should cancel. So I'm going to cross those out, and then that's really hard to look at, so I'm going to clean it up a little bit, get rid of the things that I crossed out. It looks like I just took something really simple and made it much more complicated. This is, in my opinion, the easiest way to solve this, so this is why I've done it this way. So now I'm trying to solve for p. I have p's on two different sides of the equal sign, so my next step is try to get them on the same side. So I'm going to take my fp here, and I'm going to move it to the other side. It's added, so in order to get rid of it, to go to the other side, I'm going to subtract fp. Whatever I do, I have to do on the other. My fp on the right side is going to cancel. So kind of clean that up a little bit, get rid of the stuff from the other side. This is what I'm left with. So pq minus fp equals fq. So now I still have p's in two different spots, but it looks like I only have one p multiplied by each variable on that side. So I can actually FOIL that out. So I can say p times the quantity q minus f equals fq. So I took these p's, I FOILed it out. If I were to go backwards and like multiply it out, I'd have p times q minus f times q. Or f times p, excuse me. So many p's, q's. I'd have p times q minus f times p. Looks a little different. That's where it came from. Once I have, next up I want to get p by itself. I want to divide by the quantity q minus f. Whatever I do on the left, I have to do on the right. So my q minus f side will cancel. I'm left with p equals fq over q minus f. So you can't just like flip-flop them. You won't get the right answer that way. So I know that one's scary. We'll do some more practice with it. To get your worksheet from the sub, go ahead and do the following 3 problems. Pause this if you need to like write the numbers down or whatever. Go ahead and show the sub when complete. If you are really struggling with it, let them know. They should tell you like that you can ask someone for help, but make sure that you like ask permission first. Don't just start talking with someone because they might think you're cheating. I hope this made sense. Good luck. Questions I'll take in class tomorrow. No worries. Thanks for listening.